Hello and welcome to another session in mathematics. In this session we'll be looking at surds, and that should be the last class in surds. But before that, let us take a review of our previous lesson. Welcome back. In the course of these studies, we'll be looking at application of surds to trigonometrical ratios. I will be looking at trigonometric ratio of 30 degree, 40 degree, and 60 degrees. Okay, so let us start. The objective of this study is to teach you how to derive the values of some angles without the use of calculator. Okay, let's take this to be an equilateral triangle, and we know that an equilateral triangle is a triangle that has 3 equal sides and 3 equal angles, summing up to what? 180. Okay, this is an what? Equilateral triangle. Let's call it A, B, and C. Now, if we bisect this triangle into 2, and then we have a right angle triangle of this form, where here is this 60 degree, here is this side 2, this is our A, this is our C. Now the angle here, by bisecting it, is divided into 2. That is 60 divided by 2, which will give us what? 30 degree. Okay, and this now is our angle 90. Now this side 2, which is down here, when it was bisected, it's not divided into 2, so we have 2 divided by 2, which will give us 1. So here is 1 cm and this is 2 cm. Okay, so at this point we then solve for this part. Let's call it x, and then call this part D, angle ACD. So from this triangle we have that line AC squared, which is our hypotenuse, is equal to line AD squared plus line DC squared. Okay, that's the formula, and we call it what? Pythagoras theorem. Okay, Pythagoras theorem. So AC squared is what? 2 squared equal to AD squared x squared plus what? DC squared 1 squared. So x squared then would then be equal to 2 squared minus 1 squared. X squared is equal to 4 minus 1, and then x squared is equal to 3, but we are looking for the value of x, so x is equal to square root of what? 3. So this point is what? Square root of 3. Okay, now we are not dealing with what? Angle 30 and angle what? 60, remember. And our hypotenuse in this triangle is the line facing what? Angle 90. So this is our hypotenuse, right? And then considering angle 30, this is our what? Opposite. And then this is our what? Adjacent. So let's go over to the next page and make it to be more beautiful. So we have something like this. Here is root 3, here is 2 cm, here is 1 cm, this is 90, this is 30 degrees, and this is 60 degrees. So considering angle 30, I told us that this is our hypotenuse. It's the line facing what? The angle, right angle triangle. And then our opposite, considering angle 30, is this line, and then this is our adjacent. So we use so ka tua. Sin theta normally is equal to opposite over hypotenuse. Is that correct? So sin 30 is equal to opposite. Our opposite is what? Is 1 over hypotenuse 2. Okay, then our cosine, which is cos 30, cos theta is equal to adjacent over hypotenuse, and then we have cos 30 to be equal to, our adjacent is what? Root 3 over what? hypotenuse, which is 2, then tan 30. Tan theta is equal to what? Opposite over adjacent. Is that correct? Our opposite is what? Is 1, and our adjacent is what? Is root 3. So these are the values of sin 30, cos 30, tan 30 without the use of calculator. Okay, so let us now find sin 60. Now considering angle 60 degree, this line changes. This becomes our adjacent and not opposite again, and this becomes our opposite. You know, the opposite is the line facing the given angle, so we are considering angle 60. The line facing angle 60 is our opposite, so this is our opposite, and this is now our adjacent. Have you seen the difference? So sin 60 will then be sine is always opposite over hypotenuse, so we have root 3 over what? Hypotenuse, which is 2. Then cos 60 is equal to adjacent over hypotenuse, which is 1 over 2. Then tan 60 is equal to, what is our opposite? Root 3 over what? Adjacent, which is 1, so we have root 3. Now we've actually gotten the values of what? Sin 60 and what? Cos 60 and tan 60. Now from this, you will agree with me that cos 60 degree is equal to sin 30, because they are equal to what? 1 over 2. Look at it. Sin 30 is 1 over 2, cos 60 is 1 over 2. Okay, also you will agree with me that sin 60 degree is equal to cos 30 degree, because the both of them are what? Root 3 over 2. We have sin 60 to be root 3 over 2. We have cos 30 to be what? Root 3 over 2. Is that clear now? Oh, math is very sweet. Okay, quickly let us look at angle 45 degrees. If we are given a square has equal angles which are all 90 degrees, and then each side are also equal. So if we bisect this square, we then have half of this. Let us take this. We have something like this, right? This is our angle 90, and this angle is 90. When you bisect it, that is now 90 divided by 2, which will give you what? 45. So here is our 45 degree. Okay, also here is 90 divided by 2, which will give us what? 45 degree. Okay, so this side is 1, this side also is 1. We now solve for this, and remember that's our hypotenuse, the line facing angle 90. So x squared is equal to 1 squared plus 1 squared. X squared is equal to what? 1 plus 1, and x squared is equal to 2. X is equal to square root of 2, so we have here to be square root of what? 2. Okay, then we have sine 45 degree and cos 45 degree. We have tan 45 degree. Okay, this is our hypotenuse, the line facing angle 90, so we have here to be hypotenuse. Considering this angle, and this is our opposite. Even if you consider this one, your opposite is still 1, so this is our adjacent. Okay, now sine is what? Opposite over hypotenuse, and our opposite is 1. Hypotenuse is what? Root 2. And then we have our cos 45, and cos theta is what? Adjacent over hypotenuse. Our adjacent is 1, and hypotenuse is what? Root 2. And tan theta, tan is what? Opposite over adjacent, which is 1 over 1, and that will give us what? 1. Okay, now also we discover here that sin 45 is equal to cos 45 degree, because they are all equal to what? 1 over root 2. Okay, so bear this in mind. Let me quickly give us a table of the values of these angles. We have this. Okay, here is our theta. We have here to be sine. We have cos, and then we'll have tan. So for angle 0 degree, sine 0 is 0, cos 0 is 1, tan 0 is 1. We'll have sine 30 degree is 1 over 2, cos 30 degree is root 3 over 2, and this is 1 over root 3. We'll have 45 degree, and this is 1 over root 2, 1 over root 2. We'll have 1. This is 60. We'll have root 3 over 2, root 3 over 2. We'll have 1 over 2, and then we'll have root 3. Okay, then 90 will have 1. For 90 degree we'll have 1, 0, and then we'll have infinity. Okay, let me go over to the next page. This is 120. 120 will have root 3 over 2 minus 1 over 2 minus root 3. Then let's go over. Remember, we'll have here to be theta. We'll have sine. We'll have cos. And we'll have tan. And we're in 120. So we'll have 135. Here we'll have a 1 over root 2 minus 1 over root 2 minus 1. Okay, then we'll have 150, and here we'll have 1 over 2. We'll have minus root 3 over 2 minus 1 over root 3, and for 180 we'll have here to be 0 minus 1, and then we'll have 0. Okay, then we'll have after 180 we'll have 270. 270 minus 1, this is 0, this is minus infinity. Then for this we have 360 degree, we have 0, we have 1, we have 0. So these are the values of these angles without the use of what? Calculator. So thank you very much for being part of today's class. To refresh your memory on what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. So far we've been able to deal with special angles using Surds. So far we've been able to find some trigonometric ratios using what? Surds. Okay, so we'll call it a day here. Do well to use the lesson note on the platform for better information on what we've done, and feel free to leave your questions or comment on the comment section. Till we meet again in our next class, stay safe and bye.